Hello everyone, this is the North American Math Contest Go Go Go. Let's now work on the problem 11 to 20. 11, let f be a function defined by this. Which of the following is true? So we know that this equation is definitely continuous. So therefore, for it to be continuous, we can then eliminate d and c. It is also impossible for it to be the vertical asymptote, because its graph is like much different. It's definitely not the asymptote, so we eliminate E, so we only have B and A. We know that at point 0 it is not differentiable because both sides not reaching the same. So therefore it's, it's continuous, but it's not differentiable because some reason. It's not differentiable because the graph at 0 is like approaches to infinity, so therefore it is not differentiable. We can then see the graph about how it looks like. It is like something this, so therefore it's definitely not differentiable. Therefore A is incorrect. Let's look at problem 12 next. Now let's look at problem 12. To make this problem easier, we need to first identify the first derivative and the second derivative. First derivative, it shows clearly here, x squared plus y. And the second derivative is 2x plus dy over dx, which is 2x plus x squared plus y. So let's check the point -1, -1 first. The point -1, -y shows dy over dx is 0, while the point 1, -5 did not state dy over dx 0. Therefore, since it is a critical point, it must be one of the relative maximum or minimum. One of relative maximum or relative minimum. So this means that we can eliminate all other three choices and only left C and D. So now we need to identify whether it is a local maximum or local minimum. To do that, all we need to do is we need to acknowledge the fact that max min. So we remember that the equation is x plus y, then we plug in x is y is equal to -1, -1. So therefore our solution is -3. -3 is less than 0, so therefore it's max. It is commonly mistaken that some people would choose A here because 1, -5 will also result in this. But since 1, -5 is not a critical point, it is not a candidate for this. It is not a correct candidate. Now let's look at the radius of convergence problem. This problem, okay. So this problem, what we need to do is we need to acknowledge the function, the formula for the radius of an interval of convergence, which is P is equals to lim k squared. Right? So after we know this, let's just simply begin. We first copy the equation, and is equal to 0. So then we can just simply plug in the equation. So it's like P is equals to lim k squared x minus 4 2n plus 2 divided by 3n plus 1 divided by x to the power of 4 2n 3n. then we get is equals to times 3n over 3n plus 3n over is our final this. So we know that we then can acknowledge the fact that things when p is less than 1 it is converge, and when p is larger than 1 it is diverge. Let's use this rule. So we know that x minus 4 squared is less than 1. So we know that the first case is x, which is less than 3, and then x is equal to root 3 plus 4. And then another thing is that x so therefore x minus 4 can also be equal to negative 3. I mean x minus 4, it can also be negative root 3 in order to obtain a positive root 3. So therefore it should be negative root 3 plus 4. In both solutions, we find out that the starting point of this and the ending point is negative root 3. So therefore our final answer is going to be root 3. Recall that, so we know that the distance is 2 root 3, and then we divide by 2 is equal to root 3. Remember, it's radius of convergence, not diameter. You can see that those 4 choices are pretty similar, so this problem possibly makes many people get the problem incorrect. Let K be a positive constant. Which of the following is the logistic differential equation? So generally, this problem is just a basic problem. So we need to first specify what it is. So we know that dk over dt, a logistic equation should first include kp 1 over k over p or kp 1 over k. So this problem, 1 over p. So this problem, we should not involving since it is dy over dt, the equation should not be involving any y, and the equation should be in a form of this. So therefore, we can see that C is the only correct choice. Remember, the logistic differential equation should not include any y, and it should be in a form of kx 1 minus x. So therefore, C is the correct answer. Now let's look at the problem 15. Which of the following is true? To do this problem, we can first understand the fact that hx is equals to fx. We can first understand the fact that hx is equal to fx, so therefore we know h6 is equal to f6. And h6 is equal to 0 to the 6 fx. And h6 is equal to f over 6. After we transform them, let's look at them one by one. So we know that the h6 is the area from here to here, which is the places I shown, here to here. From here to here. So it's definitely a much negative value. and h6 is 0 as it shows here, and h6 is the slope here, which the slope is look like this. Let me draw you this. It is like this, which is definitely positive. So therefore we can easily draw a conclusion that this is, which is equivalent to choice A. Now let's look at the problem 16. 16 is a basic Euler equation. Problem 16. Let y is equal to fx be the solution of the differential equation dy over dx equal to x minus 1 with the initial condition f1 is equal to 3. What is the approximation for f2 obtained by using the Euler's method with two steps of equivalence starting with x is equal to 1? Okay, so let's write the equation down here. So we know that the initial condition is 1, and since it is the steps of 2, delta x is equal to 0.1, so it's 1.52, and then it's equal to 3. So negative is equals to negative 2, and then the m is equals to dy over dx, y minus x, dy over dx, delta x plus y. So it's equal to 2, negative 0.5, delta 0.5 plus 2 is equals to 1.75. So the final answer is 1.75, which is D. Let's look at the problem 17. So to solve, looking at this problem, we know that to solve this problem, the only fastest way is to test them one by one through their power theories. So let's give out how to solve them. So let's try sine x first. The Maclaurin series of sine x, we first identify that f by using this, we can then list out the equation for it. Let's look at the first term. First term, f0 is equal to 0. However, the first term here is 1, so therefore sine x is not the correct answer. Do you see that? This is not the correct answer because sine x, f0 sine x is equal to 0. Then we test cos x. Cos x is just working the same way, opposite. 1, 0, negative 1, 0. So the first term is right. Now let's test out the second term. X cubed. What's the next term? F0, which is negative sine x, right? It's not, it's, yes. And F00 is equal to negative 1. So it's negative and minus x squared. So it's minus x squared divided by 2. It's also not correct. The second term for the cos x is this instead of. Therefore, we have eliminated the first two choices. Now let's work on our third choices, which is sine x over x. So we first get out the Maclaurin theory of sine x. F0 is equal to 0, F0 is equals to cos x is equal to 1. f0 is equals to 0 f. So we know the equation is now let's test about the first three terms. If the first three terms are right, then the equation is most likely right. The first three terms are like this, and then it is clearly seen that they are identical. So therefore the answer is C. You see the first three terms, they are identical. Therefore the answer is going to be C. Let's look at the problem 18. We are required to find f-5 if f2 is equal to 1. And we are provided with fx. So therefore we can use the integration formula to help us. Wait, what we are required to find? f2. Oh, sorry, I think I write the statement wrong. So it's f2 is equals to 1, and we are required to find f-5. So therefore, to find f-5, we can calculate it as f2 plus which is equals to f minus. Since those are not, you need one more step here. So it is equals to based on the fundamental theorem of calculus. Wait, but we don't need to do that. What we need to do is not this. We need to first calculate this, and by calculating this, we need to find the area between -5 and 2, right? So the area for this semicircle is equals to 2 squared 4 pi, 2 pi. So it's equal to 2 pi here. And then this is equals to 3 times 2. This is equal to 3. So 2 pi minus 3. Sorry, this is 3 minus 2 pi here. The area of here is 3 minus 2 pi. So, and then the answer is going to be, just wait me for a sec. The answer is going to be let's see the answer. f2 minus, which is equals to 2 pi minus 2. So this is the final answer for it. The final answer is 1 minus 3 minus 2 pi, which is 2 pi minus 2. So now we have completed 18. Let's now work on the 19 problem. On which graph the function fx is defined as fx is equal to x divided by x plus 2. Which point xy on the graph does f have the property that the line tangent to f at xy has the slope 1 over 2? What does it mean? This means that fx is equal to 1 over 2, and we are required to find this. So we first need to find the equation of it, like the equation of the derivative of the graph. Where's my graph? Okay, where's it? I can't find it, but that doesn't matter. fx is equal to x plus 2. Then we need to apply the remainder theorem. This is the formula for the remainder theorem. So what we need to do now, is we need to identify gx, fx, gx, f derivative x first. So we know that we can set fx as x and gx as x plus 2. So therefore fx is equal to 1 and gx is also going to be equal to 1. So it's equal to gx minus fx is equals to fg2x. So gx minus fx is equal to 2, and then g squared x is x squared 2. So do you remember that we said that it has a slope of 1 over 2? We can clearly find out that one of the solutions is x equal to 0, which accounts for 0, and x can also be negative 4. So it's equals to negative 2 and then 4. So therefore the two solutions are 0 and negative 4. Which is C. Now let's look at 20. 20 is a integration by parts problem. I think it's called integration by parts. Wait, why can't I move it? Okay, integration by parts. So the problem states that five x plus 8, x squared plus 3x plus 2. We can substitute them into this. And then we can then further simplify them into this. Where this is where we can then get an alternative equation that this is equal to 5x plus 2. ax plus 2a plus bx plus b is equal to 5x plus 8. A plus b is equal to 5, while 2a plus b is equals to 8. So therefore we can draw a solution that a is equal to 3 and b is equal to 2. A is equal to 3, and then b is equal to 2. It is clear a is equal to 3, b is equal to 2. So we can then get 3x plus 1 plus 2x plus 2, right? Wait, I think I get them opposite sides, 2, and then this is 1. What the freak am I doing? So this is 3, x plus 2, and then this is 2, x plus 1. So therefore it's 2i x plus 2, 3i plus 2 plus 2 in x plus 1. So the final equation is here after substitution. And then we know that the answer is C. And then we know that the answer is going to be you need to use the fundamental theorem of calculus. Which after adding up them, you get iron 18, which is going to be the solution C. So here we come to the end of problem 11 to 20, and I hope you have learned a lot. See you next week. Bye!